Welcome all, and thank you for joining today's Adabri webinar. My name is Matt Holstock, and I'm an enologist at the Australian Wine Research Institute. In today's session, we'll be taking a look at wine aroma with a webinar titled Struck Match Aroma, the Chemistry and the Winery Experience. The Adabri, where we are today, lies in the lands of the Kaurna people. In the spirit of reconciliation, the Adabri acknowledges the traditional custodians of country throughout Australia and their connections to the land, sea and community. We pay our respect to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islander peoples today. I'd also like to acknowledge Wine Australia for providing the funding and support for the webinar program via the Adabri Extension Project. Before we jump in and make a start, just a couple of quick reminders to anyone who is new to Adabri webinar program. If you'd like to provide a comment or ask a question, please click on the Q&A button on the bottom of the Zoom toolbar, typically at the bottom of the screen. Type in your question and click to send it through. We will hold a Q&A session at the end of the presentation, but feel free to send in questions at any stage throughout. A reminder also that this session is being recorded and the link will be sent through to you later via the Adabri's YouTube channel. For anyone who's just joined, welcome. Today's webinar topic is Struck Flint, the Chemistry and the Winery Experience. And it's a great pleasure to welcome Dr. Tracy Siebert from the Australian Wine Research Institute today. Dr. Siebert has more than 20 years flavour chemistry experience and currently leads the Adabri's flavour chemistry research team at the Adabri. Dr. Siebert has worked on many different wine flavours, including yeast-derived aroma volatiles, stinky sulfur compounds, tropical sulfur compounds, oak-related aroma compounds, and rotundant, the black pepper aroma compound. Tracy has expertise in measuring aroma volatiles using a range of high-performance instrumentation and a broad experience with many laboratory and sample preparation techniques. In 2018, Tracy completed her PhD investigating stone fruit aroma in wine. So Tracy, if you're ready to make a start, I will hand over to you.
Thanks, Matt. All right, so hello everyone. Thanks for joining today and thanks very much for your interest. So Struck Flint. So what do you think of when someone says a wine smells like Struck Flint? What does this descriptor actually mean? Flinty, struck flint, struck match, wet stones or mineral? What causes it in wine? And can it dominate the wine aroma and become too much? This character is often described in some styles of Chardonnay, but it is sometimes noted in other wines, white wines such as Riesling, and even in some red wines, Pinot Noir. Today, though, I'll focus on struck flint character in Chardonnay wine. So as many of you would know, Chardonnay is one of the oldest wine grape varieties or cultivars in the world, and it's grown in every wine producing country. It's adapted to different regions and varied climates, soil characteristics. Chardonnay is still Australia's most produced white grape variety, with about 21% of total grape production. It's grown in most of our wine regions with a choice of clones, and a range of viticultural techniques are used. After those grapes are grown and after choosing a picking option, Chardonnay allows a remarkable array of winemaking options, such as skin maceration, juice handling, use of selected or indigenous yeasts, barrel stainless steel fermentation, oak alternatives, nutrient additions, malolactic fermentation, aging in barrels with or without lees, as well as bottle aging, of course. So depending on those, the grapes used and the winemaking techniques chosen, different volatile aroma compounds, or varying levels of them, end up in the wines. Some coming directly from those grapes, or they can be made or released by the yeast during fermentation or even during malolactic fermentation, and they can develop during barrel or bottle aging. And the final mix of all those volatile aroma compounds in the Chardonnay wine, well, of course, it has a major influence on the aroma and flavour perceived by its consumer. So that's how we can get all those aroma compounds, and it can be a whole array and a very complex mix. So if we look at Chardonnay or wine flavour profiles, Anthony Saliba and colleagues did a descriptive study a number of years ago looking at Australian Chardonnay wines, and they found that there are 5 from cluster analysis, 5 distinct styles. They were the cut grass, citrus straw, your stone fruit peach, a melon, a more tropical fruit focused, and then the caramel oaky derived wines, Chardonnay wines. And then of course there's the one with it's a little bit of everything. Now if we look at that char smoky in the oaky wines, you could say that perhaps the struck flint, struck match term could be included in that. A number of those wines, 7 of them, were selected then for consumer study. All the styles were liked by different groups of consumers, mostly preferring the fruity, the stone fruit or tropical versions of Chardonnay, but there was a small group that preferred the oak-driven styles. Another study by Anthony Saliba and colleagues looked at where the flavour profiles of the Australian Chardonnay sat in the world context. And so looking at Burgundy styles, they're more mineral, citrus, and an Australian cooler climate Chardonnay was the best version to match that, closest in style. And that work highlighted the importance, though, of minerality for this style of Chardonnay. But what is this term minerality? It really is still a bit of a mystery. And it's, but ongoing from that, Joanna Gambetta and colleagues also looked at an expert panel to look at wine industry practices. And they were asked to define 4 distinct levels of quality. And the highest rated category, category A, flintiness was a desired, a desirable component. But that was like over 10 years ago or so. And it's an interesting thing to compare now with a recent Chablis wine production paper by Rodriguez and colleagues. And their minerality term, though, it wasn't clear. But in their 2017 paper, they said that it was an aroma term. They interviewed wine producers and grape growers, and they say that, that the mineral doesn't need oak or to get the flint, and also that the oak might even mask that. The wine producers try not to do anything in the winery that might mask the mineral character, and they don't think that they can increase the mineral in the winery. And I've tasted quite a few other white wine varieties, including a few Rieslings, especially in Germany, and even a Pinot Gris quite recently that was, and they were all without oak, and I saw them all as flinty. But which of those many aroma compounds that I talked about come through wine production, which one of those, or which ones of those, cause struck flint character in wine? Well, back in 2003, Tominaga and colleagues in Bordeaux first identified the volatile thiol, phenylmethanethiol, in boxwood, and as well as in some red and white wines. Now, they were looking at boxwood because boxwood's a character that is often described in Sauvignon Blanc wines. So phenylmethanethiol, I'm a chemist, so I have to put a little bit of chemistry structures up there. It's otherwise known as benzyl mercaptan or benzene methanethiol, or even just BM. It's a volatile thiol, and it's strong aroma, reminiscent of smoke, a struck match, struck flint, wet stones, mineral, gun flint, gun smoke, along those lines. And it's a really potent compound. If you do an aroma threshold in an alcohol water mixture, model wine, it's around 0.3 nanograms per litre. It's extremely potent. Now, what are nanograms per litre? It's a very tiny amount, and one of the best ways that we know how to visualize that is if you think about the volume of an Olympic-sized swimming pool, and you fill that up with model wine, and you add in 1 drop, just 1 drop of neat phenylmethanethiol, and mix it all up, that will smell struck flint, smoky. So it's a tiny amount, it's very potent. So in these early studies, phenylmethanethiol was found in some white wines and champagne with enough levels to think that they might contribute to that smoky aroma. They added a small amount of phenylmethanethiol, 4 nanograms per litre, to a wine with a natural amount of 7 nanograms per litre, and the smoky aroma intensity increased. And this sort of level matches well with the aroma detection thresholds that we measured at the AWRI at around 10 nanograms per litre in white wine and 6 nanograms per litre in red wine. In a second study, they found they were looking at champagne, and they found that interesting levels of phenylmethanethiol that they increased with age for the champagne up to 15 years, and then it started to decrease again. And in another study, they found that after disgorging, the level of phenylmethanethiol was higher than non-disgorged with aging of the champagne. So back at the AWRI, we also looked at adding in phenylmethanethiol into a base white wine, and we found that the aroma intensity of struck flint did increase with the increased concentrations of phenylmethanethiol. And also we looked at how that aroma of struck flint and phenylmethanethiol, does it actually impact or increase the smell of the reductive sulfur compounds such as hydrogen sulfide and methanethiol. So we did another study adding in those compounds either in by themselves or as a mixture, and we found that phenylmethanethiol only contributed to struck flint aroma and not to any of the other reductive aromas like rotten egg or sewage, cabbage. So even though there's been a number of wine sensory studies published since those early 2003 studies back in Bordeaux, one or more of them they used one or more of those flinty type descriptors, but only a limited number of those studies actually measured phenylmethanethiol. Now, I should point out that it's a really tricky compound to measure. These thiols, they are quite volatile, they're reactive, and they're at those very low concentrations in that complex matrix of wine. We need good analysts and very sensitive and expensive laboratory instrumentation. So not all the laboratories have that. So a few of those studies specifically targeted mineral, but no studies actually targeted struck match or struck flint. And in those few studies with minerality, they did not relate to flinty or phenylmethanethiol overall. So minerality still looks to be like a tricky descriptor. It's an aroma or a palate term. We're not quite sure on some papers which one they're talking about. Could be both. And is it the same thing as struck flint? So a few years ago, a large survey of Australian Chardonnay wines was conducted at the AWRI by Dimitri Capone and colleagues. And this survey was actually looking at the contribution of tropical thiols, your passion fruit and grapefruit type aromas, and those compounds that cause that, looking at that in Chardonnay wines. But along with that analysis for those tropical thiols, we also measured the phenylmethanethiol. And we found that, surprisingly, that all the wines had phenylmethanethiol in levels over the aroma threshold. So that was really interesting. And then using regression analysis, we found that older wines and more expensive wines, wines from cooler regions, were likely to have more phenylmethanethiol. And Chardonnay wines from Tasmania and were also generally higher in phenylmethanethiol. And that probably is likely because they were barrel fermented or had lees as well. But to get a bit more serious about this struck flint character, we needed to actually target that character and look at wines that had that character. So we did another survey more recently of 70 white wines, mostly premium Chardonnay from Australia, New Zealand and France, many described as having some level of that struck flint, struck match, gun flint, mineral aroma by the wineries themselves. Bench tastings were conducted And the aroma and flavour descriptors were requested from the bench tasters, as we call them, so it's an informal tasting, as well as a score for flint aroma. So the panellists used flint, struck match, gun flint, and burnt rubber commonly as descriptors. And phenylmethanethiol was found in all the wines up to 5 nanograms per litre, remembering that aroma threshold is very low at 0.3 nanograms per litre. From the rating of struck flint by the panellists, I also calculated a struck flint aroma strength and as a percentage, and that correlated with the concentration of phenylmethanethiol. Another related sulfur compound, 2-furylmethanethiol or furfuryl, that was also measured in the wines, and that's been suggested to cause coffee character in wine. So when you're thinking about a coffee pinotage, for example. It's also found in wines up to a surprisingly high level at 165 nanograms per litre. And 2-furylmethanethiol was higher in New Zealand wines, Tasmanian and Western Australian wines, and also that correlated to higher priced wines as well. So, but some of the panellists noted this transition from a complexing, quite nice struck flint to a less pleasant sulphurous burnt aroma. And to investigate that a bit further, I looked at all the information, collated the descriptors used by the panellists for the 15 wines with the most or the highest struck flint aroma strength. And on the plot here, the bigger the circle, that's the more often the term burnt rubber or burnt was used by the panellists, such that wines with higher 2-furylmethanethiol were more often described as having that struck flint with burnt rubber though. So how much flint is too much? So we'll talk about this a bit later. So from those wines, we selected then 24 wines for a comprehensive sensory and chemical study, and we aim to include a style spectrum from peachy through to flinty, representing warm and cool climates across Australia. And the wines were just from Australia and New Zealand that time, from 11 different regions, numerous price points of 4 years, across 4 years of age. It was a full descriptive study, and that we found that there was a relationship between the concentration of the sulfur compounds phenylmethanethiol and 2-furylmethanethiol, and correlated with the intensity of the struck match flint aroma. And the significant compounds for flint aroma by regression analysis were acetic acid, the oak compounds for methyl guaiacol, guaiacol itself, eugenol, and the oak lactones, and then as well as 2-furylmethanethiol. As well as that, there was a positive correlation to phenylmethanethiol and a couple of the reduced sulfur compounds. But do customers, or consumers I should say, actually like this character? So a subset of the Chardonnay wines were selected from those 24, ranging from peachy to high struck flint, and they're circled there on the screen. And from the data in the indicative matrix plots of liking on the left, you can see that the most liked wine was the one from Morning Peninsula, the MP, and it was moderate in struck flint and moderately high in peach. And if we look at the cluster analysis on the right-hand side, consumer acceptance decreased as the intensity of flint struck match aroma increased. 2/3 of the consumers preferred the fruity wines, high in peach aroma, sweetness with a bit of viscous mouthfeel, and that were low in struck match aroma. But cluster 2 liked some wines with the struck flint, with the pungent toasty flavoured wines and low in hotness and bitterness. So a really important thing to do after we do a big wine chemistry and sensory study is, of course, we like to do more sensory. This time we added the compounds of interest, phenylmethanethiol and 2-furylmethanethiol into a base wine to see what changes it makes to the aroma. So we took 5 concentrations of phenylmethanethiol that we'd found in our survey wines in the past, and also 2-furylmethanethiol. And then we did all the combinations that you can of those. So we end up with 25 samples. That goes through to descriptive analysis, and then a lot of statistical analysis. And one of the ways of showing this was using a response surface mapping. And on the vertical axis, you can see the flint aroma intensity. Sorry, the light's gone off because I've sat still too long. There it is, back on again. And then, so yes, on the vertical axis is the flint aroma intensity. And with the phenylmethanethiol, as you add more of that in, we get an increase in flint aroma intensity. But as we added more and more of the 2-furylmethanethiol, we got an even higher or a faster increase of flint intensity. And then adding both in together, there was a slight enhancement of the overall flint aroma intensity compared to just the one of them in there. All right. So how do we go about getting this attribute flint, or how do we control this level or intensity in the final Chardonnay wine? So, well, it's a good question, and we're still working on it. And anecdotally, industry practices such as late sulfur sprays, oxidative handling of juice, and reductive barrel fermentation are thought to be involved in producing this struck flint character. But we've got collected a few more suggestions from winemakers or ideas, and some came from Jamie Good's book, Flawless, Understanding Faults in Wine. And in chapter 6, he wrote about reduction and volatile sulfur compounds, both the good and the bad. And he quoted a few winemakers on how they go about getting this struck flint in Chardonnay. So using solids, but keeping the solids homogeneous during barrel filling. Indigenous yeast might be good at producing mercaptan or stinky sulfur compounds. More solids, the right type of barrel and special toast. Burgundy are masters of struck match. It comes early, so not likely produced after fermentation, and seems that it's stable and with copper and ascorbic acid. And the Rouleau method, now that's detailed in the book, but the part about it that was a bit different for me was that after 12 months in barrel, the wine is racked to stainless steel for 6 months in a reductive sort of storage situation before bottling. And then some other comments that we've gathered just straight to us are that juice must nutrients are important. Fine lees or gross lees, not sure which was better. Add new oak with higher toast, and that not all barrels produce not all new barrels produce stinky or flinty wine, and tight grain produces less flint. So now I'm putting out a query to you as winemakers and grape growers, perhaps, that might be listening today. If any of you have ways that you obtain flinty wines regularly, then we'd love to hear from you via the chat today, or email me directly later on, or through the AWRI help desk. That would be fantastic to give us some ideas of what to chase in the future. So what have we found at the AWRI in any of our winemaking studies? So looking back at Dimitri Capone's and colleagues' work as part of that tropical thiol study, they had Chardonnay juices from 16 different regions in Australia sent through. The grapes were processed in a very similar manner. They were sent over refrigerated to our WIC winemaking services, and they then were made with the standardized winemaking, no oak influence, a couple of months after bottling. A couple of months after bottling, they were all the aroma compounds were analysed. They went through sensory descriptive analysis, and then some of the wines went to consumer preference study. So the thiols were confirmed as major contributors to flavour, with the 3-sulfonyl-hexanol and 3-sulfonyl-hexyl acetate contributing to those tropical aromas of citrus and grapefruit and passion fruit, and then at higher levels, quite tropical, and the phenylmethanethiol adding to the struck flint match aromas. And all the wines, surprisingly, contained phenylmethanethiol, and as I said before, no oak was used in the winemaking for these wines. And showing here is the flint aroma intensity did correlate to the phenylmethanethiol concentration. And so all of those wines would have had some sort of flinty aroma. So another trial that was done by Martin Day and some others at the AWRI, and they were looking at how different approaches to oxygen exposure during normal course of winemaking can passively add oxygen. And so they handpicked a lot of grapes, and then there was 2 styles of pressing: aerobic press mode, so normal press mode, and then they did an inert press mode, so using nitrogen gas in the press to prevent any oxygen or air going in or minimize it. And then from each of those press modes, the juice was then handled differently, and during winemaking with oxidative, then also the normal reductive style with your dry ice covering and protecting during transfers for both press mode juices. And so that shows with the bottom, with the arrow, the very, very minimal oxygen in the inert press and the reductive handling through to the most oxygen level with the aerobic press and the oxidative handling. And this was done really overall to sort of manage oxygen during winemaking, in the hope that it could improve fermentation efficiency, could help create diverse wine styles and minimise reductive off flavours. For this talk, I looked back at the data and found that that among the many chemical differences in the wines, the ones of interest for us here were that aerobic pressing led to an increase in the concentration of 3-sulfonyl-hexanol, so that tropical thiol, as well as the phenylmethanethiol. And with aerobic reductive combination having the highest phenylmethanethiol level. And on the sensory side, over on the right, you can see that the press mode was, we had more struck flint aroma with that, and it was almost significant. All right. So looking at foliar sprays in more recent studies, basic nitrogen and sulfur formulations applied in Chardonnay and Shiraz vineyards close to veraison and 3 weeks post veraison, and they were found to have a major influence on the concentrations of thiols in the finished wines. For the Chardonnay wines, both dose rates had a strong effect on the tropical fruit aroma and flavour in the wines, but the differences in struck flint character and phenylmethanethiol, though, were very small. So it doesn't look like foliar spray did a lot for struck flint. So I've talked quite a bit about phenylmethanethiol, what it smells like, that it's responsible likely for struck flint aroma in white wine, but there's still not much information on how it's formed. So looking at the 2-furylmethanethiol, a group back in 2001 at the University of Bordeaux with Blanchard and colleagues, they also identified the 2-furylmethanethiol, and that it smells like coffee, as I mentioned before, and it is in fact a key aroma compound of actual coffee. So they found that it formed in white wine during alcoholic fermentation in the barrel from furfural released by the toasted oak staves, with the fermentation conditions favourable to excess or high production of hydrogen sulfide by the yeast, and that's led to high levels of 2-furylmethanethiol. So, and of course, we're interested in both of these potent sulfur compounds now, phenylmethanethiol and 2-furylmethanethiol. But does that help us work out how phenylmethanethiol is formed? Well, if we just have that chemical reaction up there again, which we then have a look at it. So there's a similar option available for phenylmethanethiol with hydrogen sulfide and benzaldehyde. And benzaldehyde could be in the juice or in the wine as it's fermenting, especially in barrel. So to prove this assumption that both hydrogen sulfide and benzaldehyde can act as phenylmethanethiol precursors, we designed a laboratory scale fermentation experiment with low nitrogen synthetic must, so a great juice that we make in the lab, and with the intention to have a look or to encourage hydrogen sulfide formation by the yeast. So 3 strains of yeast were selected with different hydrogen sulfide production abilities, a low producer and 2 higher producing strains. And this table shows you in the middle column how much is released during fermentation, and 9 or 12 times the amount in the higher ones than in the low strain, and then how much is left in the finished wine. So again, more is left in the finished wines. So if you just do the fermentation like that with no benzaldehyde added, you see that there is more phenylmethanethiol formed with the higher producing hydrogen sulfide strains. If we add benzaldehyde, you then get no difference in production of phenylmethanethiol for the low H2S producing strain, the A1616, but for the higher producing strains, we do see a large increase in phenylmethanethiol production. So then we've also heard that or know that YAN is very important in the production of these reductive sulfur compounds, especially H2S, during fermentation. So we looked at both in synthetic must, but I've shown here the Chardonnay juice, with different YAN additions. So yeast assimilable nitrogen additions. We've added DAP to increase that. And surprisingly, the low H2S producing yeast strain had the highest level of phenylmethanethiol, whereas the other higher H2S producing strains had lower phenylmethanethiol. So we were a bit surprised by that, but it's a very interesting result nonetheless. So then we looked at pH. Is pH important? So we used 2 of the yeast strains, the same as on the previous slide, the low producer, the 1616, and the moderately high producer, 1375. And again, laboratory scale ferments on a synthetic grape must, and this one had about that moderate YAN level of about 250. And then if you don't add benzaldehyde, so again, this is just the benzaldehyde that forms during the fermentation, there is a higher level formed, or a higher level is maintained in the pH 3.5 compared to the pH 3 or the pH 4. And then if we add benzaldehyde, also pH 3. Well, the lower pHs are better at maintaining that phenylmethanethiol. But again, surprisingly, the addition of the benzaldehyde didn't actually lead to even higher levels of phenylmethanethiol being formed. Okay, so they're all ferments with yeast added in, but now we're going to look at what happens if we're just looking at it chemically. So these studies were done in ampules or and just in model wine or in wine itself. And we evaluated the effects of pH and oxygen management on phenylmethanethiol formation. We spiked in high concentrations of benzaldehyde and hydrogen sulfide, and we found that only with anaerobic conditions and at the lower pH did we get formation of phenylmethanethiol. And the high pH again prevents phenylmethanethiol formation. Then looking at model wine with phenylmethanethiol added, so we're looking at some sort of stability stuff now. And that was ampuled with different conditions, different pHs, copper and iron, oxygen levels, hydrogen sulfide levels, and SO2. And over 6 months, all showed a decrease in phenylmethanethiol, including the control, but the pH had no further decrease and a slight decrease from oxygen. But the combination of metals and higher H2S levels showed the biggest decrease. We also looked at different white wines and subsampled them out into ampules and then monitored them over time. And over 6 months, again, all wines did decrease in phenylmethanethiol, but they decreased at individual rates, so different rates for the different wines themselves. So currently, we do have some oak studies happening, storage trials with lees and oak chips, and a winemaking trial in barrels, but they are ongoing. They have been bottled, and sensory and chemical analysis will happen with those in the next 6 months. So unfortunately, I have no results to show you on those today, but we are just completing a survey on the prevalence of oak-related aroma compounds in premium wines. And we are looking at many aroma compounds from oxidation-related and nutty and caramel, etc. But here's a few of interest for this talk today. And so here's just a slide or a plot to show that all of the wines, except I think one Pinot Noir, all had oak, either fermented and or aged in oak, and the red wines were aged in oak. So looking at the benzaldehyde and the phenylmethanethiol for Pinot Noir, there's sort of a matching picture there. But for the Chardonnay, there's less of the benzaldehyde and we've got more of the phenylmethanethiol. So that's, we'll look into that further. For the furylmethanethiol, we've got a nice sort of matching plot there for the furfural. So again, the Chardonnays were all fermented in oak. So where are we at? So Burgundian Chablis aroma profile is similar to cool climate Australian Chardonnay style, or at least some of them, such as from Tumbarumba or Tasmania. And a certain level of flintiness is regarded as a necessary part of that flavour profile. We're pretty sure that phenylmethanethiol is the key aroma compound responsible for struck match, struck flint aroma in wine, but the descriptor mineral might not always mean the same thing. 2-furfuryl-methanethiol is now on our hit list, but with higher levels of the 2-furfuryl-methanethiol, we think the character can tend towards burnt rubber. Formal sensory and consumer testing gave valuable insight with 1/3 of the consumers preferring the flinty styles and 2/3 preferring the fruitier peachy style. Continued investigation is needed for both the phenylmethanethiol and the 2-furfuryl-methanethiol formation and by yeast or by chemical reaction or by a combination of that, and with and without oak. So just wanted to thank a few people, of course, Wine Australia for funding with levies from Australia's grape growers and winemakers, and matching funds from the Australian government, and the AWRI is a member of the Wine Innovation Cluster in Adelaide. My co-authors are Marlies Becker, who has left the AWRI now and has gone to the University of Queensland back last July, but she's still collaborating on a number of these projects, and she looked after a lot of the chemistry in this, what I've reported today. And Lee Francis, who was the team leader, gone off again, the team leader of sensory and flavour group until he retired after 35 years at the AWRI. He retired in June last year. Damien, Eleanor and Desi do all the sensory studies and a lot of the data analysis for that. Lisa, Flynn, Ali, Deanna and Sheridan are my analysis people that do a lot of the all of those thiols as well. And Flynn, I don't know if I said Flynn, and Sheridan's helped me organise a lot of the wine samples. We thank our sensory panellists, can't do anything without them, WIC winemaking services, and for all the help that we get from the Australian wine industry and our collaborators. So thank you very much.
Thanks, Tracy. That was great. Look, just like to remind everyone, if anyone has a question, Tracy will be online with us for next, or as long as we need, but at least for the next 3 or 4 minutes, just to send the questions through on the Q&A tab at the bottom of the toolbar, and then just press enter and it will come through. Okay, so Tracy, the first question that's come through is, I'll just read it out. Did I miss it, or was there any difference between new oak and old oak?
We haven't looked at that yet, and there's not a lot of research out there for these compounds and oak. There's a lot of oak research out there, but not a lot with these compounds. But it is certainly something that I want to look at. Anecdotally, then that toast in a new oak barrel certainly seems to be part of it, but we haven't done any studies on that yet.
So just following on from that, and you may have just answered that question. So do furfural volatiles from oak have a direct influence in the development of 2,4-furfural-methanethiol?
Well, that's what we believe, but the only study really was that one back in 2001. And hopefully the ones that we've got in bottle now, we can show that a little bit. But we're still waiting.
Okay, another question is, what's the source of the compound in grapes? Is it a direct correlation from grape juice to wine levels, or is it entirely built within the wine?
So for phenylmethanethiol, we're not 100% sure. We think the benzaldehyde must form during the fermentation, but we don't know what the precursor for that is in the juice. For the 2,4-furfural-methanethiol, that does seem to be directly from just the oak, and then the H2S from fermentation.
Okay, there's more questions on relating to oak. In reference to barrels stored in low temperature cellars, 5 to 10 degrees, producing more sulfides.
I don't know. I would have to go and investigate that, I'm afraid.
Okay. Another question is, please remind me if I'm correct, potentially less DAP during fermentation might result in more favourable flint?
So there was one of the studies you get with, I suppose, with lower YAN, and then not adding in any more DAP, you can get more hydrogen sulfide. But the study that we did when we added the DAP, we actually saw more phenylmethanethiol, which, as I said, did surprise us. But so we need to do a little bit more research on that. And I have been chatting with our microbiologist, Tony Cordente. I don't think I acknowledged him. That was very bad of me. Tony Cordente looks after all of our microbiology side of what we do.
Just pivoting back to oak again, there's a question regarding tight grain oak. Can you expand on why tight grain may produce less flint?
That was just a comment made to me by a winemaker, and that's, again, I would love to do all these research studies, and I'm hoping to do some. But if the wine industry wants it, then we can propose projects, and hopefully we can do them.
Okay, just linking back to the work done on the Chardonnays from different regions, how many Tumbarumba Chardonnays were looked at, and what were some of the key defining points and descriptors from this region, and did any regions stand out?
They were just because they were the cooler climate ones. I can't remember off the top of my head how many were from Tumbarumba. Probably not a lot. We gather a number from as many regions as we can. So you probably only had 2 or 3. I think I probably mentioned that just as an example of where cool climate Chardonnay comes from.
And did any of the regions stand out?
For struck flint, again, the Tasmania and Western Australia, cooler regions, stood out, but that's that's as far as we can go. Again, we don't get enough. We would need that many many samples from each region to follow that through as to whether any regions can produce it more reliably than others.
And it was only cool climate regions, was that correct?
We saw more of it in cool climate regions, but again, that could be that's the style that they're going after. I did think about that tight grain again, and it could be, and I haven't looked at it, but it could be that if the grain is so tight that perhaps it's harder for the furfural to come out and go into the wine, to dissolve out into the wine. That would be my thought, but again, I haven't looked at it yet.
Another question come through. Do flint characters reduce with bottle age, or do they evolve to other compounds with age?
We see that so far that if the bottle is unopened, that it seems to stay around. So we've had some wines that have been quite a few years old, probably 10 years old, and they've still contained that those compounds, 2-furylmethanethiol and the phenylmethanethiol, but we haven't done an actual long-term stability study there. That's a rare thing to do. We can only look at wines that are older and see if they still contain them. The wines that we subsampled out into ampules, we did it as carefully as possible in an anaerobic hood and things like that to minimize any oxygen that could go in and react. But they did all decrease over time. But it would, I would like to do a stability study in bottle, but we haven't done that, no.
I think there was a slide on this earlier in your presentation, but does wild fermentation influence PMT/flint aroma? And are copper additions detrimental to PMT?
So this will probably need Marlies for this a little bit, but so for the wild ferments, again, you don't know what's in the wild ferment. So as you've seen from my slides, the inoculated yeast can have all sorts of different abilities to produce hydrogen sulfide, and as we think that's very important for this, I would imagine that the indigenous yeasts will also have different abilities to produce hydrogen sulfide, which we think then is helps with the production of the phenylmethanethiol and furfural, or 2-furfural methanethiol. For the copper, I think copper fining it's not as detrimental on this as it is potentially for the tropical thiols. I know that the chemical study that was done in the ampules was copper and iron, and that did affect it, but they were at quite high levels and just in model wine. So there's no other compounds in there sort of to take a to complex and mess up those sort of reactions. They're much easier to happen chemically in model wine. So I can't really answer that one. I would have to come back to them, investigate that and come back to them with that. And do you have that, Matt? Do you have who's put the question through, and I can?
I do. We can chase that up. Absolutely. Sure. And there's just one more question that's come through. Any indication if greener pick or a riper pick might have an impact on flint levels?
That I don't know. I haven't looked at that.
Okay. And there's one regarding malolactic fermentation and PMT. Has there been any investigation on the effect of malo on the production of phenylmethanethiol?
Not that I'm aware of, but I'm sure Peter Costello would love to do one. I believe he's done a webinar recently, Matt, did he, on malolactic?
Peter. We can chase that up after. Look, there hasn't been any more questions come through. I think you've done really well there, Tracy. There's quite a few came through quickly. Look, if there's no more, I'd just like to thank Tracy for joining us today and providing a great insight into Struck Match, character in wine. I'm sure everyone who attended today got a lot out of the session. I'd also like to thank you, the audience, for logging in and taking part. And I'd like to remind you that, as always, you will receive a link to view the recording of this presentation, which will be available on the Adabry's YouTube channel. So thank you again, and I look forward to seeing you at the next Adabry webinar.
Thank you very much.